Stratospheric Sulfate Aerosols, a Search for Solutions project for CPSG 200 SGC Colloquium. Aerosols are tiny particles suspended in the atmosphere and can come from natural or man-made sources. The direct effect is being able to scatter sunlight back into space, which contributes to a cooling effect. Their indirect effect involves modifying the size of cloud particles, which changes how clouds are able to reflect and absorb sunlight. Stratospheric sulfate aerosols are particles of sulfate that are suspended in the atmosphere. They are an aspect of solar radiation management that focuses on geoengineering as a method of curtailing the effects of global warming. However, sulfate aerosols do not reduce the amount of greenhouse gases present in the atmosphere. The aerosols would be injected into the stratosphere via high-altitude planes, which would need to be designed for the purpose of carrying large payloads at high altitudes. The high-altitude planes would be called sulfate aerosol injection lofters, or SAIL for short. The injections would be done over a 15-year time span. The injections would be done roughly 4,000 times per year in year 1, increasing to over 60,000 per year in year 15. The combined cost of designing, manufacturing, and operating the aircraft, plus the cost of chemicals for 15 years, is roughly $36 billion. Injecting sulfate aerosols into the atmosphere would not decrease the amount of carbon dioxide in the atmosphere. It would only mediate the effects of increasing carbon dioxide levels. Due to a lack of reduction in carbon dioxide levels, ocean acidification would continue to worsen, and human activities would likely not engage in an effort to reduce CO2 levels. Sulfate aerosols would cause the world to experience a cooling effect, which would decrease ice melt and reduce sea level rise. The injection of sulfate aerosols into the atmosphere carries the risk of unknown side effects on a global and potentially irreversible scale. Because of their ability to reflect sunlight, sulfate aerosols create a temporary cooling effect. This could help reduce and potentially reverse both sea and land ice melt, which in turn would reduce and potentially reverse sea level rise. There would also be an increase in plant productivity, which would cause an increase in the terrestrial carbon sink. However, injecting sulfate aerosols into the atmosphere could have unknown long-term side effects on human health. The aerosols would also slow down the regeneration of the ozone layer and allow for the continued ocean acidification due to the lack of reduction in carbon dioxide. The aerosols would also create a haze effect, which would decrease the efficiency of solar power. Finally, the cooling effect that the sulfate aerosols provide is only effective as long as the aerosols are continuously being pumped into the atmosphere. The major drawback of sulfate aerosols is the fact that the atmosphere is a shared resource, and what one country does, everyone feels the effects. While coastal countries would benefit from the reduction in sea level rise, inland countries in Asia and Africa could face potential droughts due to a reduction in precipitation because sulfate aerosols can change the formation of clouds. This solution faces the legal challenge of whether or not it is possible for a country or a coalition of countries to inject sulfate aerosols into the atmosphere without unanimous global approval. The aerosols would need to be delivered at least 16 kilometers from the ground, with the ideal height being around 20 kilometers. Many aircraft either cannot reach the desired altitude or are incapable of carrying large cargoes, making the venture very costly. Thus, special aircraft would need to be designed specifically for this project that could reach the necessary altitude while carrying a heavy cargo. The cost of designing and manufacturing these aircraft is estimated to be roughly $3.6 billion. Sulfate aerosols would create a cooling effect, offsetting global warming. However, sulfate aerosols do not reduce levels of carbon dioxide, and the strategy adds to the level of carbon dioxide in the atmosphere due to the amount of flights required. This solution is also not immediately applicable due to the necessary technology still evolving. Finally, enacting this solution would likely require unanimous global approval, which is unlikely to be achieved. And here are thy text citations and image citations.